All right, so we're looking at graphing quadratic equations. Oh, how so much fun. And here on page 221, or actually starting on page 220, we're looking at some features of a parabola. And three things we're going to take a look at here are the axis of symmetry, the Y-intercept, and the vertex. Now, here we see quadratic equation in standard form, and we can use this equation to come up with several features of this graph, and that's what we're going to discuss here. Now, the first is the y-intercept. Now, we know that if we want to find the y-intercept, we set x equal to 0, and that will give us the y-intercept. But when we're looking at a quadratic equation, if you'll notice right here, if I got ax squared, well, let's do it right here, ax squared plus bx plus c. Now, if I set a equal to 0, x equal to 0, I got a times 0 squared plus b times 0 plus c. Well, these two right here being times 0, 0 squared is 0, a times 0 is 0, and b times 0 is going to be 0, and so I'm going to be just left with c. And so when I've got this quadratic equation in standard form, this c right here is actually going to be the y-intercept. Now, axis of symmetry. This is where if I were to fold the parabola in half at a certain point where I would fold it in half, it would equal each other. And I can determine the axis of symmetry by this equation right here. Negative b over 2a is going to give me both the axis of symmetry, and it also is going to give me something else. It's going to give me the x-coordinate of the vertex. Negative b over 2a. Axis of symmetry, y-intercept, and the vertex. Let's go look at an example. We'll be moving over to page 221, example 2. All right, so here we've got a function, f of x equals negative 5x squared minus 10x plus 6. And we're asked to do several things here. So the first thing we're asked to do is find the y-intercept along with the equation of the axis of symmetry, and then follow that with the x-coordinate of the vertex. Well, the y-intercept, let's just look at that. Well, that's just going to be this value of c here. Remember, our standard form is ax squared plus bx plus c. And so this positive 6 is going to be our y-intercept. So our y-intercept is 6. Now, the equation of the axis of symmetry. Well, the equation of the axis of symmetry is negative b over 2a. And in this function equation, I've got negative 10, negative 10 being b, over 2 times negative 5. Well, let's see, negative 10 is going to be positive 10, so that's going to be 10. And 2 times negative 5 is negative 10. And so my axis of symmetry is negative 1. And that is also the x-coordinate of the vertex, which is going to also equal negative 1. Now, the next step, it says make a table of values that includes the vertex. So if I'm making a table of values, I'm going to put this right here. I got x, y. We have this function equation, negative 5x minus 10x plus 6. Well, let's start with, we're going to include the axis of symmetry at the x-coordinate of the vertex at negative 1. So what happens if x is equal to negative 2? Well, I plug in negative 2 for x. Well, negative 2 squared is 4. And negative 5 times 4 is negative 20. And then negative 10 times negative 2 is going to be positive 20 plus 6. And so that means then what? That when x is negative 2, see, 4 times negative 20 plus positive 20, okay. Then x is going to equal 6, is that right? 6. Plug that back in here. Make sure that's right. Negative 5 times negative 2 squared, which is 4. Minus 10 times negative 2 plus 6. Okay. Negative 20 plus 20 plus 6. Yep, it's going to be 6. All right. Now, when x is negative 1 at the vertex, let's see here. Let me move it down here. I got negative 5 times negative 1 squared. Well, negative 1 squared is just going to be 1 minus 10 times negative 1 plus 6. What's all that going to equal? Well, I got negative 5. And negative 10 times negative 1 is plus 10 plus 6. And so at the vertex, I got negative 5 plus 10 plus 6. That's going to be at 11. And how about when x is 0? Well, I already know what that is. That's going to be 6 again, because that's the y-intercept. So there's a table of values. I could put more. I could do negative 3. I could do positive 1. I could do all that. But all I really need is just a few points on here to graph it, which is the third part that it asked me to do. So let's start down here. I got negative 1, negative 2, negative 3. And up here I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have enough room. Let me redraw this. Let's go down here. All right, negative 1, negative 2. I got that on my table of values, and I'm going to have to go up as far as 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so when x is negative 2, let's start here then with the y-intercept. When x is 0, 1, 2, 3, 4, 5, 6. There's the y-intercept. When x is negative 1, we determine that y is 11. So let's get that point on the graph. I think that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to be right here, the vertex. And when we said that x is equal to negative 2, y is equal to 6, we're going to put that right here. Let's just connect the dots. And our graph is going to look something like that right there. Okay. Pretty sloppy graphing, but here's the key thing. X-intercept is 6. The axis of symmetry is negative b over 2a, negative 10. Our axis of symmetry is at negative 1. That's also the x-coordinate of the vertex right here. And there we are. Axis of symmetry, y-intercept, and vertex of a quadratic equation.